wheels that were used in this controls. We evaluated the first at PTC with laboratory testing and on-track testing, and finally moved to revenue service in 2009. And that testing is still ongoing, we will conclude next year. This kind of summarizes the HPW1. There are 4 types of high-performance wheels still in that test. And this graph shows just the top 3 performers. The red dots show the high-performance wheels and the sample wheels removed from that test. The blue dots are the Class C wheels that have been removed. And you can see there's a lot of Class C wheels that have been removed. And the slope of the line for the Class C wheels is quite a bit steeper, indicating a higher removal rate and much less for those 3 wheels. If we took all the high-performance wheels as a group, it would be very similar to the Class C, but removing one of the types that have the most removals, quite a difference for those 3 best performers. So with the separation of the confidence intervals as well as the change in the slope of the lines, there was definitely a statistical difference in an improvement over the Class C. So we decided to make a new test called High Performance Wheel 2. And why a new test? Well, the other test was going to conclude soon in 2019, and we needed to evaluate the skills that have been developed since the previous test began. So this test is a little bit larger. It's got 11 manufacturers. It's got 14 different types of vehicles. And the flags at the bottom represent countries that submitted wheels that are participating in this test. The structure will follow the same as the HPW1. It's got laboratory testing, durability testing, on track to TTC, and finally moving into revenue service testing. This page summarizes the mechanical results. By the way, all the supplier names are confidential, so we just assign them supplier numbers to keep it confidential. The upper right graph shows the ultimate tensile strength over temperature. 2 of the suppliers were a little bit low in the limited testing we did. Not a big concern, less than 5%. The dashboards on the lines on each slide represent our minimum requirements. Same thing for the tensile strength, a couple were slightly below. For the fracture testing on the left side, all the suppliers did meet the minimum requirements. Another property we looked at was microclimates to evaluate the quantification of oxides, sulfide inclusions, and voids in the sample. The image analysis software we use samples 238 fields on a sample, and for each pixel in the image it captures, such as the one on the left, it will evaluate the grayscale intensity of each pixel, and if it falls below a certain threshold, it's counted as an inclusion or void. In this case, we didn't do a standard test. We called all the discontinuities, we just lumped them into one group, and that's flagged on the right. So the red pixels on the right could be a void, oxide, or inclusion, or a sulfide. We count them all the same in this test. So one of the questions we wanted to answer, does the microclimateness vary with depth? Hasn't been a lot of data on that, so we decided to look at the near surface as close as we could under 5 millimeters, especially near the depth of the maximum shear stress, about 5 millimeters, and also deeper into the rim. And as I said, we grouped all the discontinuities into one type of, one sort of sample. So the results, I missed something on this slide. Instead of just doing the test at the standard depth of 12.7 millimeters, we sampled at multiple depths. So we got as near to the surface as we could and tested approximately 1 millimeter at 1 millimeter intervals down to about 20 millimeters. So this is the result we got. Most of the samples were in a fairly tight band, between about 0.35 and 0.1%. The x-axis is the area or volume fraction of those discontinuities, and y-axis shows the distance from the tread surface. So, as I said, there wasn't a lot of variation in most of them. There were two over there on the right that showed higher values and also a little more variation. The dashed line at 12.7 millimeters does represent the standard depth, and you can see there's not a lot of variation around that depth, but there is a little bit of variation down to about 20 millimeters on those samples on the right, but as I said, most of them were pretty consistent over that range. The durability test we're conducting at our Facility for Accelerated Service Testing at TTC, also known as FAST. It's a 4.3 long kilometer loop, and it has fairly tight curves around most of it, with a couple of short sections of tangent track. And we're evaluating the wheels for about 40,000 kilometers before starting the revenue service test, just to see that there are no big issues with some of those wheels. Even though those wheels are AAR approved, we want to make sure that there's no surprises when we take it to revenue service. So for that test, we're using 40 wheel sets from those 14 different manufacturers. They're divided up into 10 newer identical wagons, open hopper wagons we got from one of the railroads, and axle load is 32 to 32.5 tons. So far, the wheels have accumulated about 27,000 kilometers, and you can see some pictures on the right there that show some surface cracking, some light surface cracking, RCF cracking in the bottom one. Others, like the one on the left, are pretty clean. But again, they're not, they haven't gone a long way, but we're still testing them. We do ultrasonic testing on them, both through our automated cracked wheel detector as well as a hand UT scan. And 2 of the wheel sets have been removed for large subsurface cracks. There's 2 more that have smaller cracks, but we're monitoring them. Other tests we do when we evaluate these, we're looking at just visual as well as tread profile, looking for excessive wear, and the ultrasonic testing. For the wear, there's been a little bit of total area loss, as well as flange width wear, but very little hollowing wear to this point. So, in summary, the original high-performance wheel test continues through 2019, and the 3 best performing wheels are performing statistically better than the Class C wheels. The next generation test, called HPW2, is underway. We've finished the lab testing. We're doing the durability testing, which should, most of the wheels should accumulate the target of 40,000 kilometers sometime later this year or early next year. 2 wheel sets removed for subsurface cracks, and the revenue service testing is scheduled to begin in 2019 under a grain train with one of the U.S. railroads. With that, thank you.